Hello everyone. I'm going to take a look at an example where we're going to decide which type of special parallelogram we have in the coordinate plane. So in this example I have parallelogram ABCD. We already know that it's a parallelogram just based on the given information, and we want to decide whether this is a rhombus, a rectangle, or a square. And we need to be able to justify that. We want to justify that using either the definition of rhombus, rectangle, square, or we can also use some of the properties that we've talked about as well, which are the theorems or just the corollaries we have as well. All right, so I've already went ahead and graphed this rhombus. So we got rhombus ABCD. Just looking at this, it looks like it's going to be a rhombus because these angles definitely don't look like they're right angles, but we have to be able to justify that as well. So as I said, the ways that we can justify it is with the definition. So I could take a look at the lengths of the four sides. I could see if they're all the same. I could test to see if these are right angles. Or the other way that we could do this, which is the way that I'm going to show you, is by using the properties of rectangles and rhombuses. So both rectangles and rhombuses have a special property about the diagonals. The diagonal theorem for rhombuses says that the diagonals have to be perpendicular, and the diagonal theorem for rectangles says that the diagonals have to be congruent to each other. So if I test those things for both rhombuses and rectangles, I can determine what kind of shape I have. So here, AC and BD, if I can show that this is a right angle, and if I can show that these two segments are not congruent, I know that this is a rhombus. So the way that we're going to do that, to compare whether or not these are perpendicular, we can do that with slopes, and then we'll also have to compare their lengths. So let's start with the first diagonal AC, and then we'll take a look at the slope first. So slope formula, subtract the y values up top, the x values in the denominator. So our two y values, we have 0 minus 6, and then the two x values, 4 minus negative 2, which is going to be plus 2. So that's negative 6 over 6. That's negative 1. And while we're doing this, let's also figure out the length of the segment. We can do this with the distance formula, or we could also draw in the little right triangle, and we could use the Pythagorean theorem. Either way works. So here's the distance formula. Subtract the x value squared, subtract the y value squared. So let's see what we end up with. So x value is 4 minus negative 2. It's going to be 4 plus 2. And then our two y values, 0 minus 6. So this is going to be 6 squared plus a negative 6 squared, which is 36 and 36, which is the square root of 72. And if we simplify the square root of 72, don't necessarily need to, but this is 6 times the square root of 2. So let's do that same thing for our other diagonal. So we want to look at BD now. So the slope, okay, so the y values, negative 2 minus 8. And then our two x values, we have negative 4 minus 6. So that's going to be negative 10 over negative 10, which is a slope of positive 1. And for the length of this diagonal, let's see our two x values, negative 4 minus 6 squared, the two y values, negative 2 minus 8 squared. So this is going to be a -10 and another -10, which is 100 and 100. So we end up with the square root of 200, which simplifies to 10 square roots of 2. So, as we can see, the lengths of these segments are definitely different. BD is definitely longer, so it's not a rectangle. But if I compare the slopes, the slope of AC is -1, and the slope of BD is +1, which is opposite reciprocals, which means that these are perpendicular, which means that this is a rhombus. So then I just want to summarize that. So I'm going to say, so since the slopes So we see that the slopes are opposite reciprocals. We know that AC is perpendicular to BD. But we also saw that the length, so AC is not equal to BD. So therefore, ABCD is a rhombus. There we go. So just using the diagonals and comparing them, comparing the slopes, comparing their lengths, we can determine whether this is a rhombus, a rectangle, or a square. If we ended up with opposite reciprocal slopes and the diagonals being the same, that means it's a rhombus and it's a rectangle, so that would mean it's a square. But in this case, just one of those things is true, so we ended up with a rhombus.